So now that we have sort of identified the whole concept of sensitivity and specificity as being properties of the screening test, and the whole idea of positive and negative predictive value for when the screening test is positive or negative, respectively, I'd like to show you what happens to those values when we change what's called the prevalence of the detectable preclinical phase of the disease. And so we're going to compare a new scenario with these numbers that we have here. We're going to compare to the number 90, 5, 10, and 95. And so in this particular situation, 90% were of all the people with disease, 90% tested positive. Of all the people without disease, 95% tested negative. And so we will do that same scenario, except instead of having them be even in the yes and no detectable preclinical phase of disease, we're going to change that proportion a little bit. So let's move down here to the next scenario. And we still have our 200 individuals, but instead of having it be 50-50 in the yes and no disease categories, I'm going to change it to be 10%. So 20 out of 200 have the detectable preclinical phase of disease. So these are people who appear to be healthy. Remember, we're doing screening, so they're not diagnosed as disease, but we're screening them. And then the other 180 or 90% do not have the detectable preclinical phase of disease. Now, if we use the same proportions, remember 90% of them were actually picked up on the screening test. So in this case, we would have 18 of them be picked up, and the other 10% or 2, we'd miss those. And so that's similar to what we saw in the previous example. Before, we had 95% of the time we were right when a person didn't have disease. So remember, we want people to be in these two categories here. In other words, we tested them correctly. And so 95% of 181, I believe. Let's calculate that really quickly. I believe it's 171, but I just want to check. Yes, so we have 171 here, and the other 9, we were wrong. Too bad. The screening test said they were positive, but they really weren't. So if we do the calculation here, out of 27 and 173, then we could still calculate the sensitivity. Remember, of those with disease, what proportion had a positive test? So that would be 18 out of 20, and that still is 90%. The specificity is equal to, of those who do not have the detectable preclinical phase of disease, what percent tested negative? So that would be 171 over 180, and that's 95%. And if you notice, our sensitivity and specificity did not change. Oops. There's our sensitivity and specificity. And that's because, by definition, we didn't change it. Sensitivity and specificity are considered properties of the test, and they don't move around. Now, that can't be necessarily said for positive and negative predictive value. And so let's go ahead and calculate those for this particular situation. So PPV is equal to, and one of the things that I want you to notice is that this 18 and this 171 are always the things that are the numerator. We never use the 9 or the 2. Because those were wrong. We're asking what percent of the time were we right. And so a lot of times it helps to kind of point those certain things out. So the predictive value of a positive test, in other words, here I have a positive test of all of those who tested positive, what percent of the time was I right? So 18 out of 27. So that would be 2/3 of the time, or 67% roughly. And a predictive, the predictive value of a negative test, so negative predictive value, is of those who tested negative, or 173, what percent of the time were we right? Or what percent had a negative test? So 171 over 173, and you can see that's actually pretty high. Or 98.8%, so we'll just say 99% of the time we had a negative predictive value. So what I want to ask you, let's go back up here and actually fill in the numbers from before. 90 out of 95 is equal to 94.7, and 95 out of 105 is 90.5% of the time. So what happened to those numbers as the prevalence, basically the prevalence of this detectable preclinical phase, went from 50% down to 10% of the population, or of the people that we screened? What happened to those numbers? Basically, as the prevalence goes down, this positive predictive value also goes down. So the predictive value of a positive test, we got a positive test, what's the predictive value of that? It drops as the prevalence goes down. Sensitivity and specificity didn't change considerably. What happened to the negative predictive value? It went from 90.5 up to 99. And so as prevalence goes down, negative predictive value goes up. And I want you to think about it this way. If the prevalence goes down, basically what we're doing is we're looking for a needle in a haystack. And so we're bound to get a lot more hay and a lot less needles, and so it kind of gets mixed in. We're picking things out that we think are actual cases of disease, but we're more likely to be catching these non-cases because there's just a whole bunch more of them. And so that's what happens as prevalence drops. And so a lot of times screening tests are evaluated in one particular population, maybe a really super high-risk group, where you do have more of a situation where half of the group ultimately is going to have the disease and the other half is not. And then we try to take that screening test and use it in a situation where the prevalence is just a lot lower. Not very many people in that particular population have the disease that we're screening for. And so you can also think about it this way. As this number approaches 0, this number also goes down and down and down and down. The only number that's left is here. And so this really approaches infinity. If this number was 0 and this number was 0 and this number was 0, if you tested a population with a prevalence of, the ultimate low was 0, then everybody tests positive would actually be remember, this is a positive test, so this is a false positive. Everyone who tests positive would be a false positive. So it's kind of like the extreme end of that. You can work your way all the way to the extreme. On the other hand, if everybody has the disease, then the opposite would happen, where the negative predictive value would be affected in the same kind of way. So that's what happens as prevalence changes. Just remember that sensitivity and specificity are properties of the test, and so prevalence doesn't impact them the same way that it affects the predictive value of a positive test or the predictive value of a negative test. So that concludes our discussion on prevalence.